This is the EduPlay final presentation done by Team Alpha with group members consisting of Darni Singaram, Theo Brucker, Hannah Klein, and Kevin Bredhauer.
EduPlay is a study assistance application with a purpose of helping students keep track of their studying and exam schedules and habits. This application is created with Node and React.
Here are some of our most relevant user stories that describe the desired functionality of EduPlay. The first one is, as a student, I want to have my study time tracked so my brain does not get overworked. The second one is, as a student, I want to have my study breaks given to me based on the amount I have studied so I can study more as well as go on my phone more. The third one is, as a student, I want to see my study/break history so I can see my progress. The fourth one is, as a student, I want the ability to add exams and study sessions to my calendar to stay organized. The fifth one is, as a student, I want to choose the sound of the timer so I can use a positive sound to motivate me.
3 of our most important functional requirements were requirement 1, that the product shall have a built-in calendar. This is a critical requirement and is the main feature of the application. Requirement 2 is that the product shall allow users to schedule study sessions. Requirement 3 is that the product shall allow users to create deadlines for exams and study sessions. This is to allow users to decide ahead of time when they would like to be held accountable. Here we have 2 of our non-functional requirements. Requirement 16 is that users shall be able to access their calendar within 3 seconds of opening the application 90% of the time. Requirement 19 is that the system shall be capable of launching without a crash 100% of the time. The purpose of these is to create the feeling of a smooth, integrated experience for the user. We do have one security and privacy concern with the application, which is that users' study and exam habits are stored with their accounts, and this is considered personally identifiable information. Due to this, we've implemented an email-based authentication for login in place of just their username and password, because an email-based authentication is more secure.
Our use case, called Start Login, describes how the user can click the EduPlay Click to Enter button and then the Click to Authenticate button. Then they can enter a username and password. Then they must press Enter to access the app. The goal for this use case is to get the user to have an account, and the invariant is that the user needs to be connected to the internet. The preconditions are the user must be connected to the web page and the user must be in-app. Our success post condition is the user can enter a username and password and access the app's functions. The use case model displayed here shows the account actions and navigations. The Start Login use case includes the following use cases: Start Study Timer, Start Study Break, View Study History, Add Exam, and Add Study Session. Our use case, called Start Study Timer, describes how the user clicks the timer button and then clicks the Start Studying button. The goal for this use case is to keep users focused on studying for a beneficial amount of time until a study break is rewarded. The invariant is that the user needs to be connected to the internet. The preconditions are that the user must be connected to the web page, the user must be in-app, and they must be on the home page. Our success post condition is that a user's study timer starts. Our use case, called Add Exam, describes how the user can click the small calendar icon underneath exam date and then select a date. Then they can click the Add Exam button. The system will display a confirmation page. The user clicks the OK button to add. The goal for this use case is to get the user to stay organized. The invariant is that they need to be connected to the internet, and the preconditions are that the user must be in-app, connected to the web page, and they must be on the home page. Our success post condition is that the user can enter an exam date and add it to the calendar. This analysis sequence diagram describes the login to application. First, the user opens the application and is prompted to enter their credentials. Then the credentials are packaged and sent to the database. The database either denies the credentials and ends the object, or it creates a session which is served back to the user. This next analysis sequence diagram describes creating a study session. First, the user clicks the Create Study Session button. Then the user enters details of the session, which is used to create a session object. The session object is then added to the calendar. This design sequence diagram describes adding an exam to the calendar. First, add exam, and get date are sent to the database manager. Add exam is sent and saved to calendar. Then a message that says exam added is created as a pop-up window.
The domain model. This is a domain model to show how our system is connected to itself. It maps out our features and how they function. A link has been included instead of a screenshot, as the domain model will be updated as the program is updated. The user first must log in, and then they are brought to a main menu screen. To log in, use your Google Suite email or another email of your choice. When they click enter, they will be brought to the calendar. Here, they can add an exam or study session or go to the timer screen. The timer can start and stop, and the history is logged. This works the same for the break timer.
Class diagram. We created an adapter to convert time tracked via the stopwatch to content viewable inside the calendar. An adapter is a structural design pattern that allows objects with incompatible interfaces to collaborate. The purpose of this is to convert a time tracked by the imported stopwatch library into content that can be displayed on the imported calendar library. You can see a snippet of our detailed design class diagram below.
Architecture design and design patterns. For designing the architecture of EduPlay, we designed a model to view to controller architecture. We chose this architecture since we feel it is well suited for the app we are trying to make. It is a simple yet effective way of designing an app and should be a good framework for us to build on. As seen to the right in the architecture design diagram, the controller handles the create account, log in, log out, view progress, start study session, view leaderboard, and view rewards handle, which then transfers the view selection to the view, which handles the login view, the sign up view, progress view, leaderboard view, and courses view, which then handles back to user events. The view model also sends refresh requests to the model. The model stores any user account info, notifies of any state changes, tracks user progress, tracks user time, and notifies when it's time to study. This handles the change notification event, which sets sends to the view, and the model also receives the update requests from the controller. Now for a more detailed description of the architecture design and design patterns. As mentioned before, the architectural pattern consists of three components: the view, the controller, and the model. The view for EduPlay handles the UI of the web application. This is mostly handled by React and Bootstrap. The application will have many views that can possibly be displayed. The login view will display when the user first opens the application, which options to allow EduPlay to save your credentials and sign you in automatically, or make it so that you need to log in manually each time. Any interaction with the UI can trigger user events sending information to the controller to handle the inputs. The controller handles the various events from the view. These events can be a simple button press to log in or out of an account, to see how others are doing compared to you, or to see what you have studied and for how long. When an input is detected, the controller then notifies the view of any changes if necessary, and then notifies the model of any state changes. The model for EduPlay handles the data from the app. Here, the view can access any data for specific elements in the app to update the UI when a change is detected. Any state changes notified by the controller will be stored in Firebase, and a notification of a change, if necessary, can be sent out by the model to the view controller. This will allow for the view to be updated when a new item has been added or a new message has been sent out. This communication between the database and the view controller is critical in updating the information on the application. UI mockups. Here we have some of the UI mockups that were initially designed for the app. In the top left, we have the break timer, which allows you to start a new study session, display the time and how that you have available for a break, as well as 2 buttons to take you to the course page and the leaderboard page. In the bottom left, we have the leaderboard page with the option to take you home. Here you would see how well you do compared to other students that you're friends with. In the middle, we have the calendar option, which allows you to set a new time for a study session and a new date for a study session. In the top right, we have a course page, which shows all the courses that you have enrolled in that you add, and you can click on each individually and add new study times for how long you've studied for them. And in the bottom right, we have the EduPlay homepage, which lets you log into the app.
We incorporated basic tests to ensure our features were working as planned. This will help for troubleshooting later on. If a feature fails, it will also fail the test case. Our original goal was to implement 6 test cases. An important note is not all the test cases will pass, as some are for outdated features. We kept them around in case we need to revert back to an older version. For example, one of our test cases checks that the break timer is correctly displaying the right time. It does this by also starting its own kind of stopwatch and then comparing these times to make sure that it's accurate. If this test fails, we will know that the break timer is just not running correctly. That's just one of our test cases. We have a couple other. We made 7 in total. Most of our test cases were for rendering the links, because if the links didn't even render on the page, then it's important to troubleshoot to make sure that they're appearing, that people can use them in the first place. So we have our test cases for rendering the start studying button, rendering the stop studying button, rendering the login page. We also have for the calendar page, rendering the ability to add exam somewhere, and then proof that the add exam page renders as well. Current tests for this current version have passed. I know it says 2 have failed, but those were for the old versions, and these outdated tests were kept around in case we needed to revert back to an older version. So they were for an outdated form of the application. So we have 6 total test suites, testing 6 different functionalities. Like I said before, we're testing the calendar page, testing the stopwatch, the break timer, the home page. So you can see that our test suites passed, and 5 of our tests passed as well. Overall, we got positive feedback from the usability study. The questions we asked included, did you find the app easy to use? Did the app help you focus on your study task? Did you encounter any issues or difficulties while using the app? What did you like most about the app, and what suggestions do you have for improving the app? Some of the suggestions we received included adding timer sounds, grouping study sessions by subject, and to just have more on the homepage. This usability study and this focus group allowed us to implement user suggestions, and we did implement the timer sounds. That shows the responses. We had 5 total responses to one of our questions, or 2 of our questions there. The first one being, did the app help you focus on your study task? Like I said, mostly positive results, and this allowed us to have users test the app. Overall, they found the app to be formatted well and straightforward and had helpful suggestions. It was great to get user feedback if they had any issues or difficulties while using the app, to have a different perspective, because obviously as the developers, we know the app inside and out. But it was super awesome. Down there at the bottom, overall, I thought the app was a great tool for anyone looking to stay on track with their studies. The timer and calendar features were particularly helpful, and I would definitely recommend this app to others.
Application demo. The video shows the app running. Before running, make sure to use the command cd followed by a space, then type app and then hit tab. This will autofill to the application folder, then hit enter. Once you're in the application folder, use the command npm space install and let that run to completion. Once finished, hit npm space run space start. This will automatically open the application in whatever you've set your default browser to. For the percentages done on the slides for this presentation, Theo had 4 slides, Darnie had 9 slides, Kevin had 4 slides, and Hannah had 6 slides.
Here we outline some of our future work. This includes matching the UI to our mockups, as well as implementing notifications for the calendar deadlines that you set and the study sessions and break timers. We would also like to implement a chat feature between users, and we would like to create a database to store user calendars and study history, because as of right now, all stored session data is lost upon closing the app.
Listed below are links to our application. The first is a link to the GitHub with README instructions on how to install and run the application, as well as a link to Node.js, which is needed to run the application on your machine. And now I will play a video of the application running on my machine.